begin with, I want to just show a little joke up here. As an electrician, we have three-phase motors, all kinds of electric light and stuff like that. But this goes back about 10 or 12, maybe 25 years, where the boy is sleeping in this in the bed right here. There's a black line going from the bedroom along near the ceiling, and there's a little bracket there, and on the right-hand side is his desk, and there's a kerosene lamp. So when everybody goes to bed, including him, then you read a book and you want to fall asleep, but you have to get up to blow out this particular kerosene lamp. So he installed this line, and he just gives it a little puff, and that way he can blow out this lamp, you see. So that's one way to do it when you don't have electric power. But in those days, folks burned fossil fuel. It could have easily come from the whales. Moby Dick has a very fascinating story about that. And when the Moby Dick era came to an end, they had to switch to other kinds of oil so that there's sufficient in this kerosene lamp. Anyway, times are changing. We're now having computers and all kinds of fancy equipment to make life more convenient. And I have this book here called The Ancient Engineers. They talk about the pyramids and Stonehenge. And I want to just read a couple of lines at the beginning about this. Man has been very innovative, and I think there could be a lot of folks out here disillusioned about what the future may look like. But I think modern man of today can make your life quite comfortable in spite of all the negative things you hear about climate change, etc. We can participate in it ourselves. And in this little introduction by Sprague de Camp, he talks about it in a very simple way. Civilization as we know it today owes its existence to the engineers. And it doesn't mean that I'm the one, you know, I'm just an electrician. These are the men who, down the long centuries, have learned to exploit the properties of matters and the sources of power for the benefit of mankind. By an organizational effort to use the material of the world, from the world around us, engineers devised the myriad of comfort and conveniences that mark the difference between our lives and those of our forefathers thousands of years ago. Today's topic will deal with photovoltaic cell and the electric car. And I think in my introduction you learned that I had built one in 1970. And I had a lead-acid battery in it, a DC motor, and I took all the components out of the car, exhaust pipe, etc., and then the radiator, and I ran it on a lead-acid battery. And of course, that was way back in the 1970s. The car is parked right now, and I need a brand new battery. And I asked the Prime Minister of Canada if he could help me out, since I ran so many times. And he is very evasive. He doesn't want to say yes or no. And I made it very simple for him, because I have some friends in Portland, and they make the lithium-ion batteries up there. And I said, what you can do is just send the money to them, and then I'll get the battery that way. So the Prime Minister is still on a half-easen on the balance there, not knowing what to do about my proposal. We have to... I wrote a couple of other letters to the president when Obama was still in power. I got 3 letters and a postcard about similar kind of things about photovoltaic cells or even wind power. So this little booklet I just mentioned talked about early civilization. I want to go back. Quite a few folks already know a certain amount of photovoltaic, and I will get into the details. But let me explain a little story. 5,000 years ago, in northern Italy and in southern Austria, there was a gentleman who lived at the Stone Ages in those days, and he was discovered. The glaciers have melted, and a lady and a gentleman traveled in this area. It's in the mountainous area. And they got behind schedule, and they decided to stay overnight in one of the huts, which was near the alpine area. And the following morning, they decided then to go back down to Austria, to their village where they came from. And they noticed a head was sticking out of the glacier, and part of the body. And the archaeologist who went after it eventually found out it was an early man 5,000 years ago. And he, in the early stages, I thought it was maybe somebody who lost his life mountain climbing, you know. Have you ever heard about a fellow by the name of Reinhold Messmer, who has hiked up to the Mount Everest several times already and went to the Arctic, all over the place? Well, on the second day after the news came out, he went to visit the area, and there was a bow and an arrow and all kinds of things which made survival possible. But he had also a belt, and then inside was flint for making a fire. So today we use matches and all kinds of other individual modern things. In fact, we have cell phones too. But this was a very different kind of life. Everything was organic, and everything what from Mother Nature came, including the clothing. That was all. There was no synthetic products of our times as we have them. And people still raised a family and doing hunting and trapping, or hunting and gathering. And so I want to tell an additional story along that line. Knut Rasmussen from Denmark, he was an anthropologist. He, in 1932, he left Denmark, went to Greenland, and with dog team, he traveled in northern Canada from Greenland all the way to Alaska, Bosia Peninsula, all those areas. And he talked to all the Eskimos living along the line in 1932. And it was all a common language among all the northern native people, Eskimos. And again, they made their own fire with rubbing wood together. They had a block and then a little bow and arrow, and then heated it up. So what I'm saying to you is that's even in the 1930s, before they had contact with the white man, these people existed in a very, very harsh environment without trees. So when we're talking about in the near future that the automobile will be phased out, the internal combustion engine, we don't need to be sad about it. There are ways that we can look forward to the future and enjoy life. So what I was going to do here is give you a very simple illustration here. This is the life of the Earth, representing 6 billion years. And it started right here, and we're now right about in the center here. And we assume that we're going to live, this planet Earth will continue for another 3 billion years. So prior to that, we talked about it. We had, let's say, whale oil. I've just put it down like this. And then there was wind power. There was water, H2O. Where folks cut their firewood or made lumber, whatever. Sailing ships used the wind to travel. And it was a life where there lived maybe 1 billion people already at that time. And then all of a sudden, we came to the first World War. No, first Neanderthal was found 1.5 million years ago. Then the First and Second World War came, and then the fossil fuel consumption. We start here, this is about 100 billion barrels, and then here's about 60. 12 years ago, or 15 years ago, we were right about here. And now it is 100 billion barrels per day of energy consumption on a daily basis. And prior to that, as you know, we had the things I spoke about. Now, the proven reserves, including uranium, oil and gas, and coal about 300 years. But to represent this over this long distance, coal will last us maybe 350 years, United States, Canada, Russia, etc. So this curve is going to come down again, like this. And this happening, this represents maybe 200 years here. And then there's the rest of the life expectancy of planet Earth. So we will be going back to hydropower, wind, and now photovoltaic and wind power and sailing ships and numerous other things. The electric car, EV. And in 1902, there were more electric cars on the road than there were internal combustion engines. The car was called a Baker car. And the Baker car was actually a very self-sufficient unit. It had photovoltaic cells on the roof. So it got the energy directly from the sun and then made the car go. But today's electric cars are plugged into an outlet, except Steve's. Steve's has a little vehicle which has also photovoltaic cells, and he never plugs it into the grid, because the grid actually consists of fossil fuels like coal. 45% as much as coal is our electric energy. Very little photovoltaic, even though we might have a lot in Alberta here in the state of Oregon, but that's not sufficient to kind of brag about it. And the other energy would be then natural gas. But as I say, this era is coming down. There were dinosaurs here, and now this is just a reserve left over. So we have to kind of make the projections for the future. So one of those friends of ours who sat down, there's a little unit here, and I will quote it. In 1 second, the sun produces enough energy to meet the current needs of the entire Earth for 500,000 years. In 1 single second. The Earth is 193 million miles from the sun, and it takes, because the speed of light doesn't matter, it travels at 300,000 kilometers per second. It takes 8.5 minutes to get to this point. But because we are so far away, can you imagine, and I don't know the exact explanation, but if you have a tennis ball, the Earth and then the sun over there, there's something like 1 or 2 kilometers distance between the two. So there's a very small proportion from the energy of the sun hitting Earth, and we're very, very fortunate to be able to live on planet Earth. And the sun will be here now for a long period of time. So if somebody from the oil company tells you that they have the answer, that they can stretch the resources much further than 200 years, they're just not telling the truth. I have the National Geographic magazine here. It's a copy of it, and it's a special issue dealing with energy. It was published in 1981, and I made a note on the side to myself, and I read it actually in 1914. And so it was in my mind, and I'm going to read a few lines on it, and it deals with the subject of temperature change. Studies in both the United States and the United Kingdom forecast that the concentration of carbon dioxide by the middle of the next century will be double from what it is before the Industrial Revolution. Such a concentration, say scientists, could increase average global temperature by 2 degrees Celsius and the polar temperature by as much as 7 degrees. That much warming, slight as it may seem, would seriously affect distribution of rainfall and creates desert, much of northern hemisphere and the food basket. It would be an irreversible catastrophe of unparalleled magnitude affecting all of mankind. So moving forward for the electric car is a good thing, because less than a week ago, Biden made an announcement. By the year 2033, he likes to see all public transportation and private cars to be electric cars. That means 10 years from tonight, 2033. Currently, 97% of all cars are sold, so still the internal combustion engine. So it is a it's going to be quite an achievement. I guess when I reflect on what the industry has been doing for quite a number of years, going back, GM was the owner, proprietor of electric cars for quite a while, and they rented them out. And there was a time when they were all called in and crushed. And so there is a form of engineering on one side and another destruction issued on the other side. So why can we not work together and cooperate our energies and our knowledge and move in the right direction? So your president right now is announcing going into the electric car, when private sector prior to that has eliminated them. And I think who crushed the electric cars? Can you tell me the title of that video? Who killed the electric car? That's it. Long time ago, there was a very knowledgeable man. He hardly slept, and when he did sleep, he slept for 4 hours on the workbench. And his name was Edison. And he had the following things to say, which I read. I have a little portrait of him, and we all know Edison. I put all my money on the sun and the solar energy. What a source of power. I hope we don't have to wait till all the oil and coal runs out before we tackle that. And he said that, I guess, about when he was still alive. So,
when did he say that?
I should have written down when he was born, when he passed away, about 10 years before his life expired. He had said that. I didn't make any extra notes of that. I got it. Yeah, you can Google it.
Which is around the same time as Tesla.
Yeah.
So.
Mm-hmm.
Yeah.
H.G. Wells said the same thing.
Edison died in 1931.
1931.
1931?
Died in 1931.
1931, so 10 years prior to that. The town of Ashland is quite a unique place. We have the Bramo Motorcycle Company, which has made electric bikes running. And there's Bramo, yeah. And I saw one today. So Bramo, when they had this vehicle on Earth Day on display, I went and had a closer look at it. And it's a 3-phase electric motor made by Siemens. And then they use lithium-ion batteries, and it is speed controlled through frequency control. So the frequency, the lower the frequencies, the low RPM you have, and then you increase your frequencies, and then you end up with the high speed. Now, in the early days, electric DC motor, direct current motors were used, which had a field coil in it, and also had interpoles, and also an armature and a set of brushes. And then in order to get the speed control, you used a rheostat. So the new approach is by a very expensive inverter. And as I say, there is a Siemens 3-phase motor in it, and it seems to be working. And I guess many of you may have seen those motorcycles. They're incredible.
Both front and back have electric power?
Yes.
Okay. Wow.
Then you also have in the valley here Bob O'Schultz, who was one of the first people doing photovoltaic cells. In fact, we bought a photovoltaic panel from them, 45 watts. It was made by Siemens before even American companies started to get into the business, or even the Chinese, you know. Emery Lovins, another individual who lives in, don't know exactly where he lives, but he's with MIT, Massachusetts Institute of Technology, and he is an energy consultant working directly with the government on contracts and advising the directions to go with the future we have, renewable energy future we're working with. So very, very...
his book is really good.
Reinventing fire.
Emery Lovins.
Yeah.
I think he was in Colorado.
Yeah,
Colorado.
I think he lives in
Rocky
Colorado
Mountain.
too.
It's the Institute.
Yep.
I have a panel right here, a photovoltaic panel, and I brought an inverter with me. So you can get, this is, I want to explain it first of all. There's a lot of citizens who, including what True South is doing, there's 1,100 installation which they finished recently. They have 32 employees. It takes as much, almost in Canada, to over 3 months to file all the papers and the information about what you're hoping to do on a project. And then here in Ashland, I found out too, it takes only 1 day to install it, but as much as 3 months for all the preliminaries, permits, and information. You have to have civil engineers making sure that the roof is according, that it can handle the weight. So it's not, I'm not just trying to knock the system, because in Canada we do the same thing. But in hindsight, as an electrician, I could say, is it really necessary? This is all approved material, and if we have a lot of snow and the snow's on the roof, it cannot necessarily damage. I mean, a certain amount is fine, but 3 months of doing an application, in fact, you can spend as much as $150 to $200 on parking tickets in Edmonton alone before you're ready. We have had a project from a $75,000 project, and the money came from Leonardo DiCaprio. I intend to bring a map with me from Canada. Sid and I, from Alberta, as we come down here 6 months of the year, and then return back to the north again. But Alberta is it's north of Montana. It's to the east of Idaho, and then you travel another 750 kilometers to get to Fort Chippewa in the Northwest Territory. It's not even accessible by car at all in the summertime. You have to fly in or go by boat. Leonardo DiCaprio made this money available, and they asked Sid and me to go and install equipment for the seniors and youth residents so that they have renewable energy. And native people in the north are very much living an older lifestyle with Mother Earth, in harmony with Earth, more or less. And photovoltaic, it's something which is given by the Creator. And so there was no problem with them to have renewable energy. You know, it's about 4 or 5 kilowatt hours of kilowatts on the roof, and an inverter. And then when there's a power failure, they have an energy backup. In Canada, as well as in the United States, it might sound good that you be grid intertied, but when there's a power failure, you're finished. And so with this information I'm giving you here, you have a 45-watt installation. It's your private system, not interconnected with the grid. And if there's a power failure, which is very often the case in the Northwest Territory, because they're not on a grid itself, they have a diesel generator which produces the energy for the community. There's 2,500 people living there. So energy backup is important, because lots of folks are nowadays using the cell phone. And so when your batteries run down, this would be a way. Then you can have a small DVD. Your cell phone can be recharged, and other little things. There's a special, besides the photovoltaic cells which are installed, there's also and I brought one with me, it's called a charge controller. I haven't taken it out of the box. And there's several little outlets in the front here. So the photovoltaic cells are hooked onto here, the battery on the other side. And in the front, you have digital printout. You have a 5-volt jack, a 3-volt, a 6-volt, a 9-volt, 12-volt DC, and even a cigarette lighter. So you can be, and a cigarette lighter is also not necessary for smoking, but it's for the purpose of other kinds of appliances, and you've seen quite a few on the market.
12-volt interface.
Yeah, you can even charge a small electric bike battery with
What
it
does
as
something
a-
like that run?
about 180 US dollars, and they're
I'm sorry,
They've
I don't
not
think you
opted-
can charge a bicycle with 45 watts. I don't think there's enough power out
you
of a
can,
45
no,
watt.
it's a 100-watt unit they have now, and you can
Still.
expand the system to go to 200, so you don't have to actually stop there. But I'm just emphasizing that there's a lot of unhappy people. They get a certain amount of money from the city of Ashland for being interconnected to the grid, and when there's a power failure, they have nothing. But yeah, when we came up here in December the 18th, we asked the city of Ashland to give us electric power. It took them a whole year before they were ready. And our 90-watt system, which we have got two systems, we were running for 60 days on the 90-watt unit, and we were able to use a cell phone and had a small DVD at the same time. So, and our house on Oak Street is wired for 120 to 40 volts, as well as for 12 volt. There's 13 switches and about 12 or 14 lamps at the same time, so a bathroom, bedroom, etc. And they're all LED lightings. And I want to tell you more about LEDs lighting right here before we get any further. There are 4 switches up here. There's a compact fluorescent light, there's an LED, light emitting diode, there's a quartz lamp, and also an incandescent light. And I have originally wrote it down in such a way that each one has its own little advantages and also disadvantages. The prices are very high in some cases, but then the heat giving off is another disadvantage. Incandescent light is about 85% heat, and the rest is the light. And the light emitting diode is even 1 or 2% heat and 89% light. So it gives you just an idea as to how we have moved forward. Long time ago, the native people in Northwest Territory, James Bay, have a very large hydro development up there. I think it goes into about 15 or 20 billion dollars. While Canada didn't have the energy to be consumed, it went all to New York. And it was a 175,000 volt line that went directly to New York City. And so everything worked okay for a while, and it is one of the most up-to-date grid which we have in North America. In fact, the US likes to adapt to the same system and then expand to be on this new energy. Matter of fact, in that part of the world, it's Quebec, which is French, more or less. And so it's a new kind of technology we have there. So then phase 2 was on the drawing boards, and they wanted to expand it and build more equipment. During that very same time, the compact fluorescent light fixture came in. And once they started doing the calculation, they found out there's no need for that energy anymore. So the phase 2 was completely canceled at James Bay as a result of the improvement. But let me explain to you in such a way. You and I may think that changing the light bulb will save the earth. Not quite. No, it's not quite so. There's so many other things we can do besides changing light bulbs. Our lifestyle has to change. And that's the most difficult thing to do in order to live on planet Earth, which is approaching 9 billion people. I was only a few years old when the war came to an end. Excuse me, please. When the war came to an end in Germany, and it was very difficult to move around. Like Berlin was carpet bombed. There was 1,000 airplanes on the daytime, and then there came in another one. First it was the Americans, and then later on the British. The city, we had no running water, there was no electric light, and no food and no currency. So in order for life to continue one way or another, I have a little photo here. And there was a young gentleman in Germany who invented making wood gas. And there's a diagram which he had developed. And on the back of this car, you'll see a little component there attached to it. So what he would do is, I'll just make a little diagram here. He has a kind of a boiler like this with a lid on the top, and it's bolted shut. You put wood in it, and in the center is a chimney, and you have a little firebox underneath with a trap door, and so the smoke and the heat goes through the center, and this area is filled with wood chips. And as the heat from this fire goes through the center, it creates a pressure, and then you have your wood gas, and of course goes into a filter, and it's filled with wood shavings, and then it goes into the carburetor. Kind of a smaller line there. There we are, carburetor. So at the end of the World War, or even during the war, Germany, lots of vehicles were on the road with that, and it's organic, and it's environmentally friendly fuel. They were mass-produced, and wood into a gas.
Not gasoline.
No,
smoke.
just plain gas. Period.
Hydrocarbon of some kind.
Yeah, it's a method which, when you heat the wood, it gives off gases, but it's not a poisonous gas. It's enough that it will ignite the carburetor and make a 6-cylinder engine run. So there's no conversion necessary. But what they found out is you can start the car with a little bit of gasoline or homemade alcohol, and then switch over after the engine is running, and then there's no parts to exchange. So I just emphasize that what I have mentioned earlier in my little book, there's always a way where mankind can rely on other engineers. In fact, every day, because new ideas come forward. China is 1 billion people. There's at least 40 different ideas come out every day. When the radio was invented, or the telephone, or the pencil sharpener, all those things took years before, from the idea till it got fabricated and mass-produced. Sometimes the radio itself took over 30 years. If something is really good, within 2 or 3 days, it's already put onto the market. And so modern man can benefit from it immediately. I heard in the news not long ago, if you have a crescent, no, not a crescent, if you have a socket wrench, forget the name. A ratchet strap, yes. If you put a socket on it, it's sometimes hard to get the socket off. You kind of wiggle at it when it's not used. The ball bearing inside wouldn't let go. The new ones have a little pressure switch on the top. You press on it and then it comes out quite easily. Well, the guy who invented that made a deal with the manufacturer, and he got bought out $10,000. And it was just happening about 2 or 3 years ago. He accepted the $10,000 for that change. And in the meantime, the company made millions and billions of dollars as a result of this new invention. So according to the American Constitution, he has the right to go back to the manufacturer and say, look, you're making good money, why not sharing it? And he took the company to court, and he's now getting billions and billions of dollars himself as a result of. So there is a kind of a spillover, which is kind of a handy deal. I want to draw this other example to you. Long time ago, when you drive a car and it rains and it quits raining and it comes back on again, your windshield wiper has a hard time wiping because there's not enough moisture on it if it constantly goes back and forth. So he invented the impulse on it. And it's adjustable on your steering wheel or on your, and you can make it come in every 2 or 3 seconds, or even 5 seconds intervals between wiping. So Ford Motor Company, without asking permission to have that particular product in their cars, they just went ahead and did it without permission. And so the young man who invented that took Ford Motor Company to court, and it took weeks and weeks in the courtroom to deal with it. Eventually he got compensated for it, and 1 cent a unit, because in the meantime they made several million cars, and he got compensated 1 cent per his invention, because you're benefiting from that kind of a windshield wiper methodology already. So there are
Meanwhile, while he was fighting that corporation, he lost his family and everything
I
else.
know,
He
that's what I was
lost
going to.
everything. Oh,
There was a
sorry.
very, very sad story behind it. Susie's right. His entire family, only this one single son remained with him, but it was an enormous struggle.
Wasn't it Tucker, the movie?
I believe so, yes. So we have an unjust system, but with the pressure from the public, we can correct it. We have a president, you have a president who is very capable of dealing with the subject on this kind of
We
a...
need to learn how to act smarter.
Yes, collectively, we need to participate, not only just criticize government, but even like Susie does, run for the Green Party or promote the party. And, you know, there's nothing wrong with an extra party. It's not going to hurt anybody. In Canada, we have 4 or 5 of them, and you have members in the opposition from different calibers. And just like a boardroom, if you only have 2 or 3 handling the affair and they're all in favor of it, you also have shareholders who are unhappy about it, and so if you have a balance in your boardroom, you have a better corporation so that you take care. Because I think over in the long haul, I don't want to be very facetious about it, but it is a known fact that Imperial Oil was and Exxon was very much aware that this hydrocarbon curve is coming to an end, but they were not telling it in a way. They were making very good profit, as much as $27 billion a year of earnings. So the thing is, we need to have an even playing ground. The other day I was over with my son buying some wholesale groceries at Costco, and this one lady had a son with her, and the son was quite young, and he was constantly kind of, what would you say, unhappy, noisy, complaining. And in fact, Sid and I were here in the summertime. It was quite warm outside. And the mother then said, don't worry about it, Johnny. In a few minutes, we're going to be in our own private air-conditioned car. So I'm not just saying that it's a cop-out. A friend of mine who had studied outdoor education by Professor Butler at the University of Alberta in outdoor education, he said it's a state of mind. It can be very cold, but you as a citizen have to adopt it. Your whole mind and body has to, if you're living in a cold country, you have to accept it. You cannot just go from the office or from the house into the car and then into the office and back again and complain that it's cold. You have to accept it. And it's the same in the United States too. When it's very hot, you have to accept it. There's no use complaining about it. And so it's a state of mind to live in this environment. There are ways and means to go about it to keep an area cool. So I will hand it up. This is, again, one of the pictures out of the National Geographic, a centerfold. I glued it together. And what you're seeing here, and I will explain it to you, air conditioners. And I counted that there are 21 air conditioners in here. And the little machine on the left-hand side is used to run those air conditioners because the grid isn't large enough to handle that extra air conditioning. So this one is made by Cummins, and it says silent power. And then electric wires, conductors are going to all those little air conditioning. There you'll see a gentleman a young boy on a bicycle, manual energy, and then a little 3-wheeled vehicle beside it. So have a look at it. I don't think I want to say that we're energy pigs or that we are. We have to do something about it. I beg your pardon?
We are.
Addicts.
We're guilty.
You mentioned Cummins. They're the people who now own Brammo.
Right.
So what powers the Cummins unit in that picture?
Probably diesel.
It's a diesel engine running there. Who of you was in Rio on the World Conference on the Environment in 1992? There's Sid and myself. There were 2. The city of Edmonton is easily 1,300 miles from here. It's 1 million people. There were four people from the city. It's it, 2 other individuals and myself. We went to Rio de Janeiro on the World Conference on the Environment. And there we learned quite a lot. And we were tree huggers. We were doing something about the environment, like picking up Kleenexes and apple cores or some other items like in the year of 1991, there was different environment issues. We felt that paper was an issue. We didn't want too many trees cut, so we went for the plastic instead. So when you went to Brazil and you listened to the environment debate, that's for the first one that it came out after the Kyoto Protocol, an industrialist gave a lecture at the front of the desk. And he said that he was the environmental activist. And I said, I thought I was one. I'm a tree hugger. No, he was one. You know what he did? He not only invented, it's an old kind of deal, an electrostatic precipitator. So if there's a factory making all kinds of products for the consumer, and there's all this smoke going up in the chimney, and the chimney fumes again spread over the city, and then it comes down percolating. So he insisted that by the bylaws, make sure that every chimney has an electrostatic precipitator. There's high voltage in there, and electric energy goes in it as high voltage, and the molecules and particles get attacked by this high voltage, and then it does not fall out to the chimney, but it is collected, and then later on the polarity is reversed from negative to positive. When the system is shut down, then the particles are falling down, and then a truck can haul it away. So your laundry will not be so dirty or when it settles on your laundry, which is hanging outside. So what I'm saying basically is the fact that he, as an industrialist, comes forward and says, I'm an environmental activist. And so that was a complete new kind of thing that went into my mind. So when Sid and I returned back to Canada, we decided to start raising $1.5 million, and we did that among our friends and neighbors and associates. And we raised enough energy for a freestanding wind turbine. There it is. There's a little car on the bottom. It represents the physical scale. And so I took out the electric permit for the project, and we've done with 65 shareholders just about the whole package, everything. The legal part, we had enough experts within the 65 shareholders that we were capable of finding a site where we could erect it. We had actually intention to put up 4 at the same time. The pouring of the concrete, the ordering of the tower. In fact, I went to visit the factory which made the blades. They were made in Fargo, North Dakota. We went, and the unit itself came from Holland. We wanted a gearless machine. And so it was quite a nice, interesting project, and it was approved for the grid. The wind turbine is 950 kilowatt that produces enough energy for 850 households on a yearly basis. And it is something what you could do if you have the energy. And for us, it was a piece of cake to do that. And so I became an environmentalist as an industrialist, putting up a wind turbine. And the life cycle, or the full life expectancy, is something like 30 years. And some people say, hey, there's a lot of steel in it and plastic, etc. While the life expectancy it's not the life expectancy, the full life cycle is 3 months. That means the energy which this wind turbine produces and sending it into the grid, for all the energy it took to get the wind turbine from point A to point B to the site, the concrete, the labor, etc. So within 3 months, it is cleared up all the hydrocarbons, as an example, and then you're just nothing but free. But if you have the same machine and producing as an example, electric power using coal. Forever you have to put coal into the furnace to make this electric energy. So there's a unique way of going about it. And I think it was Susie who went to Bend in Oregon. There was an annual general meeting of the American Wind Energy Association. It was quite a unique experience to be among industrialists who are really moving forward. If you take the time to go down the Columbia River Gorge, you'll see quite a number of wind turbines. And Sid, my son, has worked for Vestas of Denmark and Enercon from Germany, and they put several wind turbines on the grid. I'm just a little bit further away from my wind turbine from my photovoltaic project. That's a project Sid was on. It was 100 megawatts, 33 wind turbines, each one 3.5 megawatts. That's a very nice project.
How many houses would that do electricity?
Sid, you tell us.
So the 100 megawatts is kind of a theoretic production. You never actually achieve that.
This one,
So
pass it around.
So the practical output is more like 90 megawatts. However, there's a little margin built in, so one wind turbine could be down and it could still produce 90 megawatts. Dawson Creek is mile 1 of the Alaska Highway, and laws have been passed to where we have what's called the WAC Bennett Dam, and we can't export any of the power unless there's a certain percentage of it that's renewably generated. And so that wind turbine farm allows hydroelectricity from the WAC Bennett Dam to be exported. So it kind of meets the legal requirement. And as good as it is, it's, I guess you could say, a legal necessity.
So how long do those turbines live? How long, what's a regular
About
life?
30 years.
Yeah.
Just 30 years.
And they're subject to rebuilding. You can put new ball bearings in, new
Right.
blades if necessary. Some electronic equipment might go on a fritz. It can also be exchanged. So it's just each turbine is interconnected with a telephone. In fact, the suppliers usually knows that the turbine is down, and let the installer know that you better go out to field that turbine is down. Not necessarily that you're losing money, but the idea is to, that's what you have a maintenance group for. And Sid is quite good at it. 19 towers he can walk up. While in Germany, as an example, every wind turbine has an elevator in it, and so his knees are quite damaged, from the constant climbing. So you have to be very careful when you're a maintenance man on the wind turbine. This machine here has a transmission in it, and these ones are gearless. There's a field coil and a magnetic field making the energy, while here it is a transmission, and they run at 32 RPMs, 100%, while this one here depends on a very, very small amount of wind. The wind turbine already will produce it for the grid. So there are 16 to 18% more energy efficient. I talk about efficiency at the moment. If you drive an electric car, just switch back to the electric car for a moment. You put gasoline in it, and then you drive it. If you put in $60 worth of gasoline in your car, an electric car will do only $6. And the reason is that the internal combustion creates so much heat. The gasoline engine is only 14% efficient from energy input vis-a-vis energy output, and diesel is 2% higher. If you have an electric motor in a car, you're getting close to 98%. So that's why when you put $6 in on electrical energy, and if you get the energy from the sun, as we've talked earlier, then you're not even buying grid energy. It has coal in it as well. So there's a lot of an improvement, and then also less CO2 emissions as a result of that.
Can you charge a car off an electrical system you have in your home with solar panels?
Well, if you, like in the case of Steve's, he has
I
5
do
kilowatts
too
on the roof, you
also.
can do it. And Susie has an electric car, yes, it can be done. There's no
That's a
problem.
breakthrough right there.
Yeah,
How come-
except that they,
So one thing you're saying, Jerry, is fossil fuels are putting greenhouse gases into the air, which is warming the earth, but also burning them
yeah,
is wasting a lot of energy as heat, which
exactly.
is also heating up the planet.
Yes, it is, it's true. I have a frame of a motor vehicle here, and it's called a hybrid, which has a gasoline engine in it and the electric motor. And so if you go through the motion as to our modern mind can tell us, you notice if you have an electric car, you have an electric motor in it, a rear end, and a set of batteries and the controls. This one has the engine in it and the electric motor, and so this car is never plugged in to get the energy from the grid. It makes its own electricity and then it goes into the battery. So it's a convoluted approach toward, it's not self-sufficient, but what I'm pointing out to you that it is less of an efficient car because it uses its own system to make electric energy.
Each wheel is an electric motor or a generator?
No, it comes directly, the motor is coupled with the engine. There's a special clutch in it, and then it
hybridized.
allows it to turn over. But still, the energy is made from the gasoline, which is contradictory to our modern way of thinking. So you're better off to have an electric car. This is just a frame, and it shows you the complications.
Yes.
We had discussions here in Ashland. There's a SOHIVA, there's the Southern Oregon Electrical Motor Vehicle Club. And I think what I'm trying to point out to you is they're very knowledgeable people. There's a lot of Tesla cars running around here, and Steve is one of the members. I have participated numerous times on Zoom nowadays with these folks. And there are people here in the valley which I have to give them a lot of credit for. They're tinkers, I call them. And they are working on their own to convert a conventional half-ton pickup truck into an electric car.
Why not?
And the batteries are available. All that hardware is here for years. It started even way back in 1970 already that we had the batteries, the motor, and the technical training too, like electricians. And so there's no problem that this is a kind of a, what you call it, it's not a,
Off-the-shelf technology.
yeah, off the shelf. Also, it's not a greenhouse energy, but there's another name, it slipped my mind, I
Might
can't.
be a new business a person could start.
Yeah, it could
Even
be,
here in the valley.
yeah.
Re-innovating older cars like Toyotas, those little Blazer, all the small cars. Turn them into electric cars. They're worth a heck of a lot more
Yeah,
money than electric.
there's a
motors
company on
we
East
have.
Main that there's a company on East Main that specializes in vintage and collectible vans and cars and
Like
vehicles.
Volkswagens and.
Yes.
So,
And, yeah.
Make them into electric cars.
Yes.
Right on.
Jerry,
Right on.
Jerry, I have a
That's cutting
question.
edge right there.
That's never gonna, individuals need to
Yes,
just
go ahead,
like
Steve.
get rid of their cars and start co-oping
I have
transportation.
a question about wind generators. I've seen some pictures of windmill farms, in particular in like flat prairie type territory. I was wondering, what is the design parameters that determine the density of the turbines? Of course, landscape is a very important thing. The amount of wind, as we've already studied here in the valley, is of issue. But if you have a large area like the Plains area in central North America, what determines the density of the wind turbines on the landscape? I mean, you can't have them touching each other, obviously, but how far apart
It's
they are from each other?
It's,
What determines that?
calculations, and it's aero interference when they're too close together. Engineers have designed it. Usually on 40 acres you can put 6 wind turbines, but also according to the local rules and regulations, you cannot have, in case there's a problem with your tower that might fall over, it should fall over on your own property, not on a property adjacent to it. So you have to back off a little bit. When we worked on our own wind turbines, there's documents you have to file with the department. And so it is out of the hand from the electrician's perspective. But it is all in the upper classes of the engineering division. And I think we hired those people. We were lucky. We have limited shareholdership. As many as 60 you can have in Canada before you go public. So it's a private corporation. And we had lawyers within our group and a chartered accountant, electricians and concrete people and carpenters setting up forms and rebar. Go ahead.
Out of all those shareholders, how many households
850 households.
and how many were there out of those shareholders of the
Right
project?
to the, we had 20 always at any one time out at the job site assisting on the project. And it was a learning experience for all of us.
Right, but how many households were shareholders?
Everyone who is a house owner, we didn't have, there was none of us who was an apartment owner or condominium owner. They were private household owners, and I think it was kind of a handy way to, I wouldn't say that it is a negative thing, but with my son Sid and Steve and Susie of the Heide and Frank, we have a green energy wind power, and I produced this product. Here's about 250 pages. It's a wind energy portfolio which I made available to Mr. Clark, who was then the head of the Ashland Ski Hill. All the environmental issues are mentioned in here. It's a portfolio designed for Ashland. We intended to have a wind turbine farm in this area because we have currently 6 anemometer towers in the valley where we collect wind data and determine in what area we want to go and look at it.
What's it cost for 6 windmills?
Well, 3 wind turbines would be $3.7 million to make it possible. But the data we have collected, and I believe I have somewhere in my collections, I have a photograph of an anemometer tower. I want to just let the wind energy go for a little while, and I'll move to Steinmetz right now. Go
I
ahead,
just wanted
Susie.
to ask you a question about your turbine in Canada. That's got to be getting close to 30 years old now,
Yes.
so
20, yeah,
you
it
know,
was,
what are you looking at going forward? Replacing a few pieces, or?
the generator the ball bearing is bad. It needs to be updated, and we have to hire a company with the crane, and cranes are very expensive. There's bringing it to the site and then removing it is all involved, and it is called $75,000 for bringing a crane in. They're usually in the 400-ton capacity with a very high boom.
So how do you handle that on your shares? I mean,
It,
do people understand that they'll
Oh,
have to do
yes,
maintenance 30 years
we've
down the
taken
road?
all these issues into consideration. We have a slush
Can you buy
fund.
insurance that would cover that for damages?
It would, but then your rates will increase. We do it as a maintenance routine, and we set the money aside in case there is a need for it. When it also happens that the grid goes down in an area like that, and all the wind turbines shut down temporarily, and then during that time the brakes go on, and then we have our disc is scorched from the brakes, and so that has to be.
If it goes down, you'd have to turn the windmills
It
off.
goes automatically. It's all done through a
Automatically
program.
turn
Even though
So-
the wind's still turning them?
No, that's
Well,
not.
it goes on idle, and we usually stop them. And but in the meantime,
Waste.
if you have inexperienced maintenance people there, they could foul up the system. And so we were in an unfortunate situation where we had somebody not quite being up to date, And Sid can tell you a little bit more about those details.
So the older wind turbine farms did have to go offline when the grid was no longer available. The current ones can consume their own production with a chopping circuit. So for about 15 minutes, they consume their production. The grid tries to reconnect 2 or 3 times before a fuse blows. And so a wind turbine farm of a more modern manufacturer has a capacity to stay online consuming its output for 15 minutes. And if the grid continues to be unavailable for 15 minutes, then they drop off. But it's the old ones that dropped off immediately and then had to be brought back on each time the grid is interrupted.
So they don't continue spinning.
The newer wind turbine farms are able to continue for about 15 minutes.
Yeah, they're clutched.
So go ahead, Steve.
Would you like to take a 10-minute intermission?
Yeah, we could do that.
I just want to bring up one issue, is that, did we ever get an owner on the freeway? Because China has vertical access wind turbines.
Yes.
And all the semis going back and forth power the cities on the side of the freeways.
That's brilliant.
Yeah, because all the truckers are going continuously, and those have the vertical access, are just sitting there spinning both directions and powering the cities on the freeways.
Why don't we do that?
Because we're idiots.
Well, I know that.
China has got more people in one county than we have in population of our country.
Yes, yes.
One county is larger than our country. Japan has the same amount of people as the United States on an island the size of California.
I think it's half the size, 125.
Yeah, we should have,
Should we take a?
we should have a
people.
10-minute break and then we can,
I think Japan's half the size.
Maybe,
Yes, a tiny
maybe in
country.
the second half,
California,
we
the
can have
size of our
a
state, yeah.
question and
Everybody in the United
answer
States
session.
moves to China.
yeah, I have a little bit left to
is
talk
the worst
about
place
the
right
electric
now.
car and then we can, yeah, we can have all kinds of questions, sure.
Let's go LA. Talk about it.
It's fine with me.
It's all
How
underwater.
much do we make an
Sounds like
electric
you're
car
full
for?
of-
It's all
Say that again?
flooded
How
out.
much do we make an electric car for?
Pistachios,
How much
strawberries,
are a
everything's
car,
gone.
regular car,
Yeah, they
electric
do a
car,
lot
how
of
much does it
production.
cost?
Can I ask what your
20
background?
grand.
Um,
Most of them make
$12,000 at the very most.
And I'm
More-
also
more
doing
than that.
electric cars.
There's going to be
electric
millions and
vehicles.
millions of cars if it's an internal combustion engine lying around. They don't need to be crushed. You strip them, and I call it cottage industries. 2 or 3 cars can be converted by 2 or 3 technicians, and then put them on the stream. So you need to buy the battery. Exactly. There'll be a lot of employment here in the valley by itself. There'll be no problem. In Europe, there's a lot of wind turbines, as you probably know in the news, that Germany is now burning coal again, unfortunately, because they'd like to cut themselves off from Russia so that less money is going there, because they used to buy natural gas from them. So they have, over a period of time, phased out their nuclear energy, and they are quite far ahead. I think over 27% of the energy on the grid is wind energy. And Denmark is also 25 to 30% on wind, and so is Spain and Portugal. Enormous amount of improvements have been made, moving away from fossil fuels. There's the French government is getting uranium from Canada through the Crown Corporation in the province of Saskatchewan, and they're hoping to phase out some of the nuclear energy. The recent statistics show that the proven reserves of U3O8 is a very limited amount. In fact, I hear in the newscast at times Canadian and American governments brag about the clean energy, and it is, if we go and switch to nuclear, we have maybe 4 or 5 years of energy on that one end too, and so it is a very limited amount of fuel at the same time. It may be clean, but again, the transition period could be in wind and human energy, horsepower, etc. You know, there's 35,000 horses idle, hobby horses doing nothing. And in the early days, they used to plow the fields. Farmers used to use them. Anyway, I've put some statistics here on it. The wind turbine we have in Pincher Creek among our shareholders is 0.1 of a megawatt, 0.9 of a gigawatt. A very small amount. So Oregon has 4. Yeah, kilowatts. And California 6, Washington 3.95, Montana 4.1, and Idaho 0.9. But the total in the US is 139 gigawatts, and I don't know what ratio it would be from the grid. I have a chart which shows it in gigajoules. It's an older item which I have here. Let me get it out. I can't get my hands on fast enough. It's in here. Anyway, we have to leave that for some other time, this particular issue. I don't have it here. Anyway, I want to switch quickly on the last little item. These towers are quite tall. They're 40 meters, which makes it 40 yards more or less. And there are 27 tons apiece, and they get bolted together. There's 60 bolts in between the two layers, and I brought one bolt with me. The tower is about over 4.5 meters in diameter at this end. And the first tower is put up, and on the lower part you have the inverter and all the electronic stuff. And then there's a stairwell in it, and then the second tower portion is added to it. And so there's a row of bolts. So when you look at a tower, you don't even see the bolts. They're inside. There's a flange welded, and then they are attached. So I brought that with me so that you have an idea. So we more or less covered photovoltaic, the wind power a little bit, and I have a few things to say about the electric car. Long time ago, there was a Model T Ford, and it was quite often in use. And one of the owners went to see Ford, Henry Ford, and says, you know, there's something not quite right about this car. It has a generator in it, and when I'm driving on a highway, my light would be nice and bright, but when the car's idling, the lights go so dim. What can it be? So Ford sat down with Steinmetz, who was the chief electrical engineer for General Electric, and in a matter of 20 minutes, they have this problem solved. And Steinmetz says, what you need is a battery and a voltage regulator. And you see the same thing applies to our wind turbines too. If you have electric energy and the demand of the energy isn't there, then you pump water up to the reservoir, and then when the wind isn't blowing, you let the hydro energy come out. So the water reservoir is where the three-phase motor sends it to the top. In the car, yeah. Nowadays, the modern approach would be an ancillary battery. And so the project, when you are putting up wind turbines, you install several of those sea cans full of battery, Tesla's batteries as an example, and then manufactured by Mr. Musk, very expensive. But then you have energy to back up during the time when there's a demand. It's a special kind of engineering, but this engineering is being taught at the university level, so there's no difficulties whatsoever to have ancillary trailers loaded with it. So here was a project where Steinmetz was involved doing something voluntarily. He'd never charged for it, and all of a sudden we have a battery in the car and also the voltage regulator, and the voltage is level now in the car. So this is an approach which, through harmony and cooperation, that we achieved it without fighting with each other over this issue. Steinmetz was also a very clever man. He used in the early days we had these electric cars, and he had a mercury rectifier, and he had the, I guess in this case, the grid can go into this armature, so a set of windings, and it leads into the left and right hand side into the mercury rectifier. There's a little starting mechanism, and then the batteries are here for charging. So you make out of AC energy DC. And so the early electric cars didn't have a system where they could, let's say, plug it in their own private house. It had to go back to a kind of a garage and get the energy charged. And so the mercury rectifier was the first one. It was out. And then much later came the diode as we have them today. I have a diagram of it. You know what it looks like.
Does that hold electricity?
Yeah.
I did like this one.
So
It's a one-way valve.
It's one way, yes, with capacitor.
A one-way valve?
Yeah.
then you can also charge a battery using the electric grid by having an MG set. It's a motor generator. It's a three-phase motor, and it's coupled with a DC generator. Give you DC, and then you have DC. DC goes like this, a complete line, horizontal. Alternating current would be this way. 60 cycle hertz goes like this. From here to here is 1/60th of a second, and it's a halfway. So when you rectify electric energy with a single rectifier, this is the with a single rectifier. There's the rectifier. You only have the upper part. The lower one is skipped. There's a rectifier here. Then the advanced one is a full wave rectification where you have 4 rectifiers, and then you have energy with a tiny little bump like that. And when you put capacitors in it, you have pretty well half even energy straight for the battery. The other way is you can use an alternator and rectify it, which is the same thing, or use an armature with brushes. Then your energy is also nice and smooth. The brushes and the commutator will make it. There's a set of poles, magnetic contact up and lower and upper. Another way of doing, if the diodes are very expensive, what you can do is, I guess I don't have to really do it on the blackboard. We can just hand out the unit. 2 rectifiers can be used with a center point where you have the primary winding and then the armature here, and then have 2 diodes, and you get 100% full wave rectification with 2 diodes. Full wave rectification are, I guess I drew it on the one sec already on the blackboard. The
Which of these
What-
is the most efficient?
photovoltaic is the most efficient, and from an energy
No, I mean,
perspective,
The rectification.
full wave rectification. The mercury rectifier is already phased out, and we've now moved into the diodes to do this project for recharging a battery. There's a myth about this whole thing. People think that they have to go to the city of Ashland and plug it in there. No, with the rectifier, each car has its own rectifier in the vehicle, and it can be charged by just plugging it into a standard outlet in your own house. You don't have to actually go and purchase the energy when you're on I-5. In fact, there's a proposal now. In fact, it's under construction. Is at Indian Memorial Road. There's going to be 35 stations up there for plugging in.
24 stations on Clover Lane.
Yeah, Clover Lane. So if you do your own, then it comes out of your own electrical grid. If you use photovoltaic, instead having to buy it and then let it go through the credit card system. And if you don't make the payments on the credit card, then you pay 19% interest, unfortunately. With Mario Houle, who's here, he's a carpenter, contractor. He built about 8 or 9 straw bale houses in Canada, and everyone was out in the bush, and our company installed photovoltaic equipment off-grid. This is part of the lecture. So here's a Canadian contractor who has been doing straw bale housing for a long period of time, and our company, we are limited in Canada with SID. Our corporation got, in 1968 is when we began our project, and we had a lot of government jobs at the university and with hospitals, etc. So we were able to have a few extra dollars lying around. Electric, in the early days, there was a gentleman by the name of Jacobs, Marcel Jacobs, and electrification wasn't achieved at that time, so he had his own little wind turbines making electric power. It was done on 32 volts. He had all the batteries made, glass batteries with lead acid, and there were 32 volt washing machines, 32 volt light bulbs, the whole ball of wax, and he patented about 35 different kinds of engineering with this company. And when you are designing even a pumping unit like this, which you still see at times, he didn't have a wind tunnel in which to test. So he had a half-ton pickup truck. There was a driver. He told him to drive 50 kilometers an hour or 50 miles an hour. And he had the wind turbine on top of the half-bound flat deck, and he made the various adjustments to change the pitch, etc. In fact, he came forward with a 3-brush generator for voltage control, etc. So Marcel Jacobs was very innovative. He had nothing to begin with, and he built up the company of his own. And I'm just wanting to emphasize, if an opportunity exists, the ingenuity is among the citizens. Let the government participate at times and let them come forward with venture capital. That holds the country together, and it makes the people participate. Frank, during the recess time, spoke to me, how come China is so far ahead? How come they're doing everything? Well, we as Americans and also Canadians or Europeans have to pull ourselves together. We want to participate in our change, and we can be part of it. And our government has to recognize that we're willing to make this happening, instead letting other nations come in and bring it in. In fact, I learned too that if you live in California, there are so many trucks coming in when the ships are unloaded from China, and the highway is full of semis with products from China. So my way of thinking would be, it would be good to turn around and have employment and made in USA products, so this can easily happen. Oh, here's my diagram about a diode, and you need only 4 of those for your rectification. Another thing which I've done, and this is again, I'm talking about private experience, 1981 or so, before I went to Rio. This is a bicycle with a dynamo inside the hub before the electric motors were installed. And you see a lot in Ashland now with the electric motor. It's 3 watts, 6 volts. And I put, the tire has still air in it. There's a tube in it. And I made my own blades, and it had a pitch of 6 degrees. And there I am at a tower. That's my company truck. And we had our own Earth Day. And so this was a unit I'd taken various places and explained that energy from the sun and from the wind can be harnessed, and you can move forward with that particular arrangement. I have another example here, and I want to talk about how electrical energy is made. I have an ampere meter here, a voltmeter, with a center off position. On this side is a permanent magnet and an electric coil from a telephone. And here is a dynamo on the right-hand side. So what I want to explain to you, magnetism exists in here. And when a magnet is in contact with an electric coil, an EMF, an electromotive force, is created. It goes back to the laws of physics. And so if I move this magnet up and down, the magnet is going through the electric coils and producing this electrical energy. And you see the fluctuation in the instrument going up and down. So I can eat all kinds of food and a slice of toast, And I won't be able to do very much like that. I will get soon tired by doing this. And I thought, why don't you let the wind turbine do it? I'll flip the switch. There it is. Can you see it? That's your concept of getting the energy from the wind. I don't have to do it the old-fashioned way, you know. So this is just an example as to how the energy goes back to the folks like Ampere and Volta and Henry and Ampere and also Hertz, etc. And James Watt, etc. So this other example I have here, it's, I had another part. Oh, here it's on this side. This is one form of electric energy to be made using the magnetic coil. There's two other projects making electric energy from two dissimilar metals and acid. You put them into sulfuric acid, a piece of wire made out of copper, and another one being zinc. And then through the acid process, you have electrical energy. But there's also a third one, which is called the Seebeck effect. And I use a match this time, and I have a thermocouple here and another board I want to show to you. Frank, would you like to come and hold it for me? So what we do is we light a match, and I hold it under the thermocouple. It's two dissimilar metals bonded together, like welded or short-circuited, and I put this match underneath here, and then it creates an electrical current, and then the instrument will show it. So it's called the Seebeck effect. These are the anemometer towers we have in Ashland. They are, I had it laminated. It's vinyl. They're sit, our little four-wheel drive, and these towers are 20 feet, 21 feet in height with the anemometer tower at the top. And we have a chip in there, 8 gigabytes. And there's also, everything can be recorded over a long period of time. And the question had come there not long ago about okay, we got 25 minutes left. In our proposal, which we made to the city of Ashland, and I had quite a number of meetings with town council in the renewable energy, of which Risa Buck was a member of, and we proposed that a gondola with our electrical system, which would generate, we would have a station in the center of Ashland at the plaza, and have the gondola going up to the hill at Mount Ashland, and then mothers don't have to take them there and then bring them back down again, constantly going up. So this would be in 2011. I proposed it. It was part of our package, and it's all identified in our portfolio on the wind power. But it was rejected. In fact, I had made 3 attempts at town council and explained our project, and not a single question is raised. Who are you and where were you born, or something like that. And that was about all the questions pertaining to the project. It's like walking against the brick wall kind of thing, you know. So here, these are 3 directors of green energy wind power. My wife Betty in the center, and Frank Marshall over here, and then Sid Paschen over at the right-hand side. Oops, sorry about that. Okay, thank you, Frank. We should dedicate the rest of our time toward the questions which could still be around.
I could just offer, so somebody inquired how close the wind turbines can be together. There's a wind shadow which you want to avoid, because if you're in the wind shadow of another turbine, then there's the reduced wind speed that the turbine in front of it creates. So, as you had pointed out, should there be a catastrophic failure with one wind turbine of a 90-meter tower height, it shouldn't fall down and damage an adjacent tower. And the wind shadow is pretty much eliminated in that distance. So if the towers are their height in distance apart, then you're pretty much avoiding the wind shadow from one wind turbine to the next. So approximately the height of the wind turbines.
What creates a bigger wind shadow, a vertical axis or a horizontal axis wind turbine?
I would say the vertical axis creates a more wind shadow.
There's a little blueprint here. France is Savonius, that's the original name being given. Canada had, through a special government grant, installed 1.5 megawatt, and there were 10 such towers. They're 40 yards high, and they have 4 aluminum blades which revolve, and the generators at the bottom of the unit. And so when the wind can come from any direction, and you don't, these ones here, unfortunately got wet. The cup of tea which was offered to me fell. These have to turn into the wind. There's a computer inside, and it changes the direction into the wind. And then also the blades they can be feathered, depending on the volume of the wind. It can feather it.
Automatically
Yeah.
variable.
It's through a computer, and it can obtain the energy from the wind at an optimal session at all times for the benefit. The vertical axis wind turbines are very labor intensive. We had on the site where we put our wind turbine, there were 10 on the project, and we had to decommission them. There were some technical problems with them, and so that's all good galvanized steel. I have 40 tons of the steel right now, and the welders don't like it because they don't want to use weld. So it can be bolted together, and I brought enough steel to Canada, to the U.S., and we built our own anemometer towers. And I think you've seen that.
Recycle.
Yeah.
It's interesting. I think there's some of those in Ashland.
That's smart.
I could speak to.
So these are the anemometer towers which we have here in the valley, and that's all Adicon steel from the French government. So they're 21 feet in height, and this upper part is the anemometer which collects the wind data. It comes from Idaho, from Idaho. Let me see, Bonners Ferry area. We have the data logger to go with it, and there's a chip that collects the data, and we can unload it later on and collect the information.
You were mentioning the variable pitch propellers earlier. The Vestas machines are not dependent on a grid or electricity to vary the pitch of the propellers. So there are nitrogen bottles, compressed nitrogen, and should the grid fail, the nitrogen can pitch out the blades. So should a tornado or a hurricane occur, they can feather themselves out and protect themselves in the case of extremely high winds or hurricane force winds.
That's smart.
So they can literally withstand a hurricane.
What is the max force wind?
So you can take them in and out of service.
You know, there
and
have been
run them.
catastrophic failures, but it tends to do with
That's a threat.
material failure. It's not
Well, you
actually-
can't do that, can you?
An overspeed can cause a blade
I'll-
to be thrown.
So Sid, I have a question for you. How many vertical axis turbines are around this valley?
Not anymore.
I think there's 6 on I-5, that's all I know.
Yeah,
There was a kite came in.
they're vertical.
Yeah. But those have a tendency to get off skid
They're-
as the bearings go out.
They're alternate a little
Yeah.
bit on the
The
top.
oscillate, yeah.
They all
You
been,
get a little whiplash going on.
yeah, but it's amazing that they're still up after about 9 years. You know,
Yeah.
it's amazing.
First 3 we've got here was by Bell Canal's place, isn't it?
Yeah, that's right.
That's where that
It's
element.
it's near I-5 as you travel
Yeah, you come out,
and
yeah.
look to the right-hand side, which is north of you will be able to see them. not far from it.
More up on the ridge.
Couple more things I want to talk about the photovoltaic cells itself. It's a crystal, and the crystal is grown in a lab under special environmental condition, and it gets sucked out of a unit, and then they're held horizontal, and they're sliced into little pieces and then attached. And there are two kinds of different cells on the market. And I made a diagram. There's the cadmium sulfate, blah, 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 and then another one. So the red and the blue, and I marked them down. So the bluer one has, according to so many wavelengths of Armstrong, the Chinese have gone full thrust into this, and they have not experimenting, they're at a stage now where they can mass produce them. Their labor is so much cheaper, and they're dumping them into Canada and into the US.
They're like screen printing them?
Yeah, it's there's also another kind which you can roll up and you can attach them to the roof. So there's
Roll up.
Flexible.
Wait about
the
that.
roll,
On the boats,
the roll,
make them out of sails.
and the roll. They're no longer very. In the early days, they were very sensitive. You could take a small spoon and touch them, and then they would shatter. They
big
are
one to
about
make 'em.
less than 1 millimeter in thickness, or 1/16 of an inch.
My vehicle
So-
has flexible solar panel on it,
Yeah.
100 watt.
Flex.
Good. Yes, they are.
Marine grade.
Why can't we make solar panels here? Why don't we
It
put
can-
people to work?
It can be done. It's a political will, basically, you know, and also we need to be very realistic about ourselves, and also our technical schools need to get trained engineers in that particular field.
Yeah.
Today, I hear in the news, and there's nothing wrong with Romeo and Juliet. Today is the first evening that Shakespeare Theatre is back in operation again. You know, and town council is being asked right now to make $3.2 million available as a grant, because they just can't quite make it, you know. So the good news is Shakespeare Theatre is back on its feet again in the city of Ashland.
The Shakespeare,
Yeah.
were they gonna close?
While there was
They could.
it was a great debate in town council about not knowing what to do with the future, but now
Season used to start in the middle of February. Now it's starting in the middle of April. That's what has happened over the
They should
pandemic.
sell out to Ashland, the city of Ashland. City of Ashland's buying everything else.
So back to solar is
Yeah.
electric
They're
vehicles.
Yes, thank
responsible
you.
by-
so what
There'd be a city-
Well, the reason I'm mentioning is because of employment. Frank's question was raised, how come we can't do it? We have to find a happy medium. There has to be a certain amount in the arts area as well as the technical end, because there's nothing wrong with music, art, and literature. It's non-destructive to the environment, but I think we are facing survival of man on planet Earth. We have now 9 billion people, and we need to plan a future whereby we can exist. So music, art, and literature is good, and so is drama. But we have to kind of balance it and let the engineers move forward in the field so that mankind can have a future. Because, go ahead, there's a question there.
Well, it's more a comment. I think one of the reasons that photovoltaics are not being manufactured in this country is because we believe in paying our people a decent wage for that kind of technical work and factory work. And in China, as you
Extortion.
may know, they
Wages are-
don't pay that kind of a wage.
The wages are
Look,
way
they're too
down.
high.
Build them with robots.
But you can't. I mean, you can't live on a low wage in this country right now,
There's new-
especially on the
We have high
coast.
inflation.
There's new technology coming out right now, and there is a system that's coming out that's 65% efficient solar. And it's based upon a tube focus Fresnel, which is logical. Focus it, amplify it, and use a new process. And those are all going to Dubai. They're not coming here. Because that's where the money's at. That's where the sun is.
There's also a recirculating solar
Yeah.
that spins.
Yeah.
Yeah, it's a matter of the wages, that's absolutely true. But then, when you think about it, I've seen so much inflation in my lifetime in Canada and Germany and here as well. Was it really necessary to go in this particular issue of so much inflation? You know, there has to be, inflation has to be under control, and it shouldn't be a freeloader. For instance, a credit card, 19% interest, it is unfair for the government to give this company so much privilege that they can charge 90% if you owe the money.
Here,
But, sorry about that, but it's
what
just...
made America great? Our innovation, our ability for technology, our ability to train our people to go to war, just like World War II. We won that by the women. They were in our factories.
Yes.
They built the products that we killed the men with.
Oh, nice. I'm glad you
Yeah, it's it takes a good leader. It takes a leader. I keep hearing in the news that Biden was in China, had meetings, he met with Putin again, and blah blah blah. So his home turf is here, you know. And it's our prime minister in Canada, same thing. They make the various trips to outsiders, and then all of a sudden we find that we have.
It is a global world now.
Right.
It is.
Nobody's
Gotta take our
isolated.
technology back. We've had so much
It's,
stolen from us.
there's a good question there,
And
probably.
the resources are in other countries sometimes.
So if there was a proposal, because that's what, like 4 megawatt systems in Jackson County that are doing solar, and one's the government, the VA, the other one's out on 234, and we got a couple up here. But we're still looking at the support from Green Springs Power Plant coming off of the
Yes.
lakes up there.
Yeah.
And so what other source do we have of backup energy that's being developed locally?
Well, we do generate electricity up on Mount Ashland.
Oh, yeah.
Yeah.
Ashland, oh, man.
Lost Creek, but that's clear up the other side. But realistically, I mean, if anything happened to the grid, I mean, can we maintain the source point?
You could. I want to elaborate for a brief moment, but there's also a question. I get back to that and go ahead, please. Give us.
So slightly shifting a little bit, I appreciate electric vehicles, photovoltaics, different types of battery storage. I've been doing that for years. And through the use, see the benefits and the pros and the cons, and there are many on both sides. So in terms of what we're talking about, renewable energy,
Yes.
and I include hydro in that. I know
Yes.
it's not popular for a lot of people.
Yeah.
But if we're looking, I guess there's a couple questions. It's the grid, the distribution system that's there. The current system that we have right now is highly inefficient.
Yes.
And most of the energy that's put into that system doesn't get to the destination through resistance.
Goes away.
And so on and so forth.
Gets lost.
So what we're talking about is great. I mean, it's kind of at the hobbyist level now. So if we're talking about replacing the existing energy system, how are we going to do that with a distribution grid that is out of date? We're pushing to electrify everything. How are we going to get the energy? Solar and wind won't meet the current capacity we have, and if we're trying to electrify everything, how are we going to meet that increased demand there? The gentleman that was sitting here that left earlier was talking about, well, just get rid of your cars and we'll just share. That's an idea. You suggested that we get a horse in the meantime, but how are we going to bridge that point between, there's a push for getting rid of all of the
Internal combustion.
anything that we burn or
Yes.
Well, we first have to reprogram the world.
Can I finish? How do we jump from where we are now to where y'all want to be, and without pushing us back into the Stone Age again? So I'm seeing what's being proposed, I'm seeing the reality of what we have, and the two aren't matching.
That's right. That's why I said earlier in my talk, our lifestyle has to change, and nobody's willing to change that lifestyle. That's why we continue on the same idea and put everything what we've learned or we should be doing on the back burner, and that's not correct. A lecture was given in Canada about renewable energy, and scientists went to the mic, it was an open mic, and everybody contributed to it, and it was not the answer. The gentleman who was the moderator of it, he says, I have a daughter who's 11 years of age. She has the answer. And it is our lifestyle has to change. All these other things are complicated to do.
I, for one, have been satisfying 99% of my transportation needs by energy coming from the sun.
There you go, that's what Edison also says, Thomas Edison had said that too. Are we willing to do it? And our government has to be an example. They have to create policies which, step by step, we're moving in a direction so that we have the American dream again, you know? So, Germany had to find a different way. They go back to coal. When the tsunami came into Japan after the earthquake has occurred, it shut down the cooling plant for
Nuclear power plant.
Fukushima's plant.
Oh, yeah.
And so the people in Japan had less of an energy. You know what they said? We are the ones who are going to cut back. We want to continue to produce a finished product for export. That's very important. So they cut back to nothing, and they went to bed earlier as a result of it. They didn't have the light for the radio, and in fact the computers and the cell phones all consume energy. And so the Japanese people decided on their own that they would cut back really drastically so that there's energy available for the export product they had. And so we've got to make a similar kind of decision.
Like a semi-indigenous lifestyle.
Right.
Hybridized.
But we need to be careful. We need to be doing it in such a way that we're not hurting it, or there isn't the mother again that says, don't worry about it, Johnny, sooner we're going to be in our own air-conditioned car. The child has to learn it's a state of mind. We live in this area which is very hot in the summertime, and we have to somehow overcome using a little bit less of air conditioning. In fact, we talked about our grid is out of date. We need to work at our university levels in the electrical engineering department particularly. We need to really move forward and make it possible that we have a grid which can extract energy from various sources, photovoltaic and wind power, with ancillary batteries to back it up if necessary when the demand is high, and also time of day with the electric watt-hour meter too. Charge at 6 o'clock, that should be the highest rate. Maybe I had a list earlier in my here in Hawaii you pay 45 cents a kilowatt hour. Here is something like 11.5. In Germany it's 19. So 19 cents a kilowatt hour. So what we could do is during the peak demands a higher rate. It's called time of day. And then when the demand is down, a lower price, and the smart meter can do all that. And so citizens learn which affects your wallet. That's when you hit the nail on the head.
Well, when you talk about Hawaii, you know 45% of their energy comes from diesel, and I never saw a place that could do sun and wind better
I
than.
know, but they have a fair amount of wind energy also.
Geothermal, they got volcanoes.
Yeah, too, right?
So,
Joe, are you aware of Biden administration just spent, put in $6 billion to help with 11 states, and the state of Oregon's one of them. They'll help put solar panels on your house if you own it. Are you aware of that? Has anybody else seen that on the internet?
Well, in Holland,
Advertise it all the time.
in Holland, as you want to build a brand new house,
Right?
you have to have photovoltaic on it, or you won't get a permit. So those are the kinds of rules and regulations we need to do here too, you
Yeah,
see?
yeah.
Well, you
Anyway,
mentioned Hawaii.
I beg your pardon?
You mentioned Hawaii.
Yes.
Any new homes that are being built there, like on the Big Island, there's no more electrical capacity, so you're required to be totally off-grid.
Yeah.
After they
How
installed
long-
all
how long
our
has this
air
been?
conditioning, huh?
Excuse me?
Yeah.
How long?
I'm an
How long is
electrical,
this, the,
No, for.
I had my,
Yeah, there's no new houses without being self-contained.
I was a journeyman electrician at the age of 19. I was in 1957. I came to Canada and I've had my own company since 1957. The last 5 years, you can't even have a 200 ampere service for residents anymore. It's illegal. The utility company won't give it to you. I look around here, I find I was 200 ampere. It's a very common service. Unbelievable. In Germany, they have 220 480 volts, a higher voltage, less amperage. There's a problem with the copper supply at the same time. Our conductors, the higher the voltage, the lower the amperage. So this is all done through the electrical engineering division, and they can make meetings with City Hall and make rules and regulations. I visited this electrical power plant on top of the hill. Produces 800 kilowatts of energy, and that's exactly the same amount of energy which the street lighting uses. So now I'm going to tell you the last little bit of anecdotal story. In Germany, there was Frederick the Great, and his people were in a smoking room having a good evening talking about it, and he left the smoking room to go to bed, and he had to walk down on along the so-called the deck, balcony kind of thing outside, and there were 5 candles were burning there during the days when Frederick the Great was around, and he blew out 3 of them and left the other 2, and he said, wax is very expensive. Well, I want to emphasize, and I made it clear to the City Hall, the day should come when we have the full moon that our street lighting is reduced a little bit. In Germany, you want to take your dog on the walk, you have to recognize these utility streetlight poles in your neighborhood. You log it onto your own telephone computer. If you want to have that streetlight, you dial it in and you pay for it. Okay, that's how you do it. And these are the kinds of rules and regulations. This is only 2 or 3 examples I give you, you know. But we must work toward something like that to make it sustainable. We want to be here. Our grandchildren are the ones who are telling us.
You carry the phone with you and it recognizes who you are as you walk down the street.
Anyway, we have to leave at 9 o'clock.
We
And
have to go now.
anybody want to join?